Let's keep going with the problem passing on the trail. I left you abruptly at the graph. And I said, hey, you guys can do this, right? Well, now you need to check your work. Draw both graphs, one representing Hans' equation and one representing Jada's equation. It is important to be very precise. That's right, I'll be checking you for accuracy. Okay, we already got Jada's equation, and the problem gave us Hans' equation. So I'm going to put that right down here where we can see it and use it. Okay, these equations are kind of in slope-intercept form. So you have to remember the golden equation, y equals mx plus b. Let me show you that these are in that form, starting with Hans' equation. Now, instead of saying y, it's d equals. And then the m, that's the slope of the line. And you see that in Hans' equation, right? Here's the m in yellow. It's here, negative 2.4. That's the slope of the line, negative 2.4. And then the x, well, we're using t. In slope-intercept form, plus b is the y-intercept. And here we have 4.8. So here's how you use it. Remember that this is the y-intercept. I taught that quite some time ago. Hopefully this is a review for you. So the intercept is 4.8, the y-intercept. That means when x equals 0, the value for d is 4.8. Just go ahead and put in t equals 0. Do the math, and you'll see that this term here cancels out when t equals 0, and you're left with 4.8. So when t equals 0, d equals 4.8. You should be good enough at substitution by now to see that. Anyway, that's the starting point on the y-axis. Now let me erase my stuff. Next, use the slope. Use the slope of the line to draw your line. The slope is negative 2.4. So when we go over 1, let me move this so we can see it right there. When you go over 1, and here's 1 on the axis, that means you go down 2.4. Slope is rise over run, but it's negative. So we rise going down. Go down 2.4 and over 1. And you have to draw that accurately. This is 4.8. So if you go down 2.4, then that's minus 2.4. And the answer is 2.4. So 4.8 minus 2.4 equals 2.4. So here is 2.4, 1. Here's another thing to point out. Now each box here, each column is 0.25. But my slope is negative 2.4 over 1. And I really hope you remember slope from a long time ago. So down 2.4 over 1. There's our next point. And then we're going to do that again. Down 2.4 over 1. So here would be the next one, number 2. Now I can draw the line for Hans' equation, and I must draw accurately. Use something straight when you draw it, please. Let me get rid of my slope triangles. Okay, so that's for Han. Now what about Jada? Jada has a starting point of 0.6. So that's 1, 2, 3, 4, here it is, 5, 6, right here. There's Jada's starting point. At time equals 0, she is 0.6 miles away from the parking lot and a slope of 3.2. So after 1 hour, you can substitute t equals 1, put that in there. After 1 hour, her distance is 3.2 plus 0.6. That's 3.8. Let's graph that point. Go up to 3.8. There's 3, 3.2, 3.4, 3.6, 3.8. Okay, right here. That's another point on the line. Now, I could find the next point, but actually I don't need to. I can just draw a straight line through those points. And it's going to look like that. Yeah, something like that. Okay, so I have accurately graphed the equations, one for Han, one for Jada. Let me erase my extra stuff here. Now read the next question, question number 6. Question number 6, find the point where the two graphs intersect each other. What are the coordinates of this point? Okay, they're asking you to look at the intersection. What are the coordinates of this intersection? Remember, when you give the coordinates, you want to give x before y. Oops, my highlighter's not working correctly. That was supposed to be a parentheses. There we go. X, comma, y. The x coordinate is 0.75. The y coordinate is 3. So the x coordinate, 0.75, comma, 3. It's a little hard for me to write with my mouse. I can't find my pen today because I can't find my pencil case. Anyway, I'll find it later. Number 7, what do the coordinates mean in this situation? Okay, what do these coordinates mean? Well, when these lines cross, Jada and Han are at the same place at the same time. So that's like where they pass each other, right? Let me say that again. Where these lines cross, it means at that point, Jada and Han are both at the same place at the same time. Jada and Han are passing the same point at the same time. They meet for just a second, and they pass. And that is at time equals 0.75 hours, which is 45 minutes. I shouldn't say at 45 minutes. I'm going to say after 45 minutes, they pass 3 miles from the parking lot. Okay, I answered number 7 completely. Number 8. What has to be true about the relationship between these coordinates and Jada's equation? Well, the answer to this is easier than you think. Number 8. What has to be true about the relationship between these coordinates, here are the coordinates, and Jada's equation? Okay, well, get this. Jada's equation is this blue line. These coordinates are a point on Jada's line. It means they are a solution to Jada's line. It's easier than you think, right? The answer is simple. The coordinates are a solution to the point on Jada's line. Number 9, question number 9. What has to be true about the relationship between these coordinates and Han's equation? Well, guess what? Same thing. These are also a point on Hans' line. They are also a solution to Hans' equation. In other words, they are an ordered pair that satisfies either Hans' equation or Jada's equation. Let me write my answer. They are also a solution to Hans' equation. That means the coordinates at the intersection are ordered pairs. Do you remember ordered pairs? Ordered pairs is a solution to the equation. And along the line, there are many coordinates or many ordered pairs that are true for the equation. Now, what was I writing? They are also a solution to Hans' equation. That means the coordinates at the intersection are ordered pairs for either line. They are a solution to both equations. They are a solution to both equations. And that is the learning goal for this assignment. The learning goal for this assignment is to see that where the lines intersect, the coordinates at that point satisfy both equations. We have Hans' equation, we have Jada's equation. And at the time 0.75, the distance is 3 miles for either one of them. So these coordinates are a solution for both equations. And on the graph, you see that where the lines intersect. Good job.